This is a typical type of vector problem involving planes and wind. And so as you read through this, it shows that there's an airplane that has an airspeed of 475 miles per hour, heading of 70. So this would be dropping, when it says heading, that's from the north side, and you drop a north-south line. So 70 degrees would be less than 90. So the first thing I'm going to do is go ahead and draw in a 70-degree vector and label it with 475 miles per hour. And so I'm just doing one thing at a time here. Now that would be the initial vector. Then there's an impact of a wind, and the wind says that's 120 degrees, which would mean that you would drop another north-south line. This is going to impact it, so that's going to be more like this, and then you're going to know that's 120 degrees. Again, labeling it as 80 miles per hour. Now that you have that labeled, the next part would be to go ahead and draw in the resultant, and that's going to be the green line. And so that's going to be the true course of this particular airplane after the wind is affecting the direction. So a couple things to keep in mind. First of all, you can use alternate interior angles here, and so this is going to be 70 degrees, and this is going to be 60 degrees because you have the sum has to be 180, and therefore you have 130 here. That tells you that in order to find your x, which is going to be the velocity, you would use the law of cosines because it's not a right angle here. Sometimes it is, but unfortunately here it isn't. So that means that x squared equals 475 squared plus 80 squared minus 2 times 475 times 80 times the cosine of 130. And when you go ahead and solve for x, you are going to get that particular number. Now, the other part of that is direction. Direction of the plane relative to the ground. So the question is, what are you really solving for? What you're really solving for is what is the direction from the north to where the resultant is, and that right there is going to give me my theta. Now, to get your theta, you're going to have to work within the triangle to get your alpha. To get your alpha, I'm looking at basically law of sines, because you have a side, an angle, and a side. You're trying to get this angle, and I'm looking for pairs here. So it's this angle and this side. I'm going to have x, and I know that angle, so I'd have two pairs here. Therefore, it would be the sine of alpha over 80 equals the sine of 130 over whatever you got for that x value. And then you would multiply by 80 on both sides and solve for alpha, and therefore you would get an alpha eventually. And with that alpha, then what you have to do is add in 70 to get your theta. So theta is going to be approximately your alpha plus 70, and that's going to be a heading of that, which means from due north, you could say. From due north. These type of problems get really tricky in terms of setting them up and going the right direction. And so take your time on the setup. The setup is by far the majority of the work in these problems, because if you make a mistake, everything else is going to be wrong. It's going to be frustrating. I would draw these things, check them with a friend, and make sure that they're correct before you went through the math.